Amigo, I am Anjali and welcome to my channel Intro with Anjali. Today Anjali is here with the topic that what makes a vehicle to e-vehicle. Simply means what are the components of e-vehicles. So without wasting the time, let us start. There are mainly three components of e-vehicles and I memorize and understand it in this way. We have three things that are input, process and output. Comparing with the EV mechanism, when our EV is running on the road, the battery is supplying the electrical energy. That means input level is battery. When battery is supplying the electrical energy, we need to control that electrical energy so that we can control the speed of motor. Overall, we can control the speed of our vehicle. And this whole control process is done with the help of controllers, and this controller is providing the electrical energy to our electric motor, and as a result our vehicles runs on the road. So motor, controller and battery, these are the three main essential components of e-vehicles, and if someone wants to explain so many components of e-vehicles, he or she can see EVA is consisting of this much components, and if they want to explain it in detail, they can utilize their time and explain it in detail. But for today's info session, I have filtered out some components which are explained and demonstrated widely everywhere. And those are batteries, motors, inverters, converters, control unit and charging. So let us begin with the very first component, that is battery. When we are talking in context of EV, the battery which is used for the traction purpose is also known as traction battery. It is the secondary type of battery. That means this battery is rechargeable. And if we are comparing it with the IC engines, just replace the fuel tank by battery packs. We know what battery do for our EV. It stores the electrical energy and provides us when it is needed. And when it comes to battery capacity, we know higher the capacity, higher the distance you can travel. That is good. Increase the capacity and drive long. But here comes the biggest challenge for today's EV technology. So, is increasing the battery capacity is this much difficult that it is a challenge for EV technology? No. Increasing the battery capacity isn't an issue. But the thing is, higher the capacity, higher the size and weight. So what? The larger and heavier batteries will not only eat up your storage space but also will affect your fuel economics and energy efficiency. And as the size and weight increases, overall complexities will increase, and at the end cost of your vehicle will increase. And that's why today 50 to 60% cost of e-vehicle is consumed by battery itself. But as per as of December 2019, the cost of electrical vehicle battery has fallen 87% since 2010 on a per kilowatt hour basis. Isn't it amazing? And with the recent battery technology and upgradation in battery which we are getting each and every day, this is gonna change the market. The next thing is control unit, and it is also known as EV control unit, EV ECU or only ECU in some literatures. And why it is so much important? Because it controls the vehicle dynamics based on the information from various EV components like inverter, BMU and battery management unit and many more things. So as its name suggests, it is a unit. It is not made up of any single component. So which components make this unit? And these components are inverters, DC to DC converters and vehicle control unit. Why inverter is required? So we are using our battery to give the supply to our motor, but the output of our battery is DC, and the supply which our motor requires is AC. So we need to convert that DC into AC, and inverter does this job very well. And if your inverter is of bidirectional category, which is of course choice of majority EV manufacturers, its functions are doubled. That means it is not only converting your DC into AC, but it is also converting the AC into DC when it comes to regenerative braking. Talking about DC to DC converters, we are using our battery to supply the motor and run our vehicle, right? But the battery is not only mean to supply the motor, but we have other auxiliaries as well, our speed controller, fuel controller, many other controllers, displays, lights, and many more things which are electronic devices, and they works on the level of 12 volt. And the output of our battery is quite higher than this 12 volt level. So we require a low voltage DC to DC converter which converts this high voltage battery output to 12 volt limit so that we can supply it to our auxiliaries. And at the end, vehicle control unit. It is I can say it is the administrative unit. Why? Because it administrates the operation and distribution of power at any given moment. And how it works, it has a microcontroller which can change the current level, or which indirectly affects the working mechanism. And this vehicle control unit is mainly used either to increase the mechanical I can say mechanical performance of your vehicle, or to suit the operator's driving style. And inverters, converters, control unit, these are the components of overall control unit, or we can say ECU. The other component which I would like to mention here is the charger. In some literature, charger is considered as a part of ECU, and in some literatures it is not. So charger is a charging element which gets the electrical energy from external sources such as grid or solar plants or any other thing, and it provides the energy to our battery. The energy which we are getting from the outer source is in form of AC, and this AC is converted to DC, and then it is fed to our battery to store the energy. We have two types of charger that are onboard chargers and offboard chargers. Onboard chargers are already installed in your vehicle, and offboard chargers are not installed in your vehicles. And last but not least, we have electric motors. Everyone knows what electrical motor does. Electrical motor is a device which converts the electrical energy into mechanical energy. This mechanical energy is in the form of rotational motion in majority of cases. And if we compare it with the IC engine vehicles, just replace the IC engine with the electric motors. And coming to the advantages of electric motors, it gives the quiet and comfortable operation compared to conventional vehicles because of electric motor. Because electrical motors are less noisy and are having less vibration compared to IC engines. And coming to some terms, 100 kilowatt is roughly equal to 134 HP. So just imagine how compact the electric motor is compared to IC engine when it comes to same output. And another thing is regenerative braking, as discussed in case of inverter, that it is converting AC to DC when it comes to regenerative braking. And this is why inverters plays a crucial role in increasing the drivability of your vehicle. And when it comes to motor, there are numbers of motors available in market. If you are thinking from mechanical perspective, its wear and tear, its torque, its strain, and many other things are come into consideration. When you are looking from electrical perspective, whether it is static or rotating, it is AC or DC, it is single phase or three phase, it is asynchronous or synchronous, it is permanent magnet or electromagnet, and many more categories are there. So the question arises is, which is the most suitable motor for my vehicle? Think on it. I will answer this question in my next session, and till then, stay tuned, stay happy, stay healthy, and sayonara.